Pre-flight 101, the course that will give you wings. 5. Aircraft systems and structures. 5.4. The fuel system. Hey guys, nice to have you here again. In this lesson we're going to learn about the fuel system. This system is the one in charge for transferring the fuel from the tanks. Remember, we have two big tanks of fuel in the wings to the combustion chamber in order to be burned for power in an efficient and safe way. We will observe that despite the small differences between the older and newer systems, the basic organization is pretty similar in the three of them, right? In the Cessna 172 November, the Cessna 172 Romeo, and the 72 SP. The differences and improvements basically come from the difference between a gas engine and a kerosene or commonly known diesel engine, right? They're different, so they're gonna become more and more advanced, and they're gonna bring with them improvements and differences. And also the difference from a carburetor engine and an injection one, right? That's gonna bring some differences as well. As we go through the slides, I'll be reminding you some of the concepts about these engines that are going to help you understand these way better. Alright, let's get started. Alright, so this is the fuel system of the Cessna 172 November. As you can remember, the Cessna 172 November features a carburetor like coming gas engine, right? F-gas is the fuel type. So this is going to bring a couple systems with it. We're going to need a primer for starting. I will show you after what the primer is. We have it here right there in the drawing. And as you can see, it's a pretty simple system. We have a couple fuel tanks, a selector, and we quickly get to the engine, right? It's not really a big deal. So let's take a look at it. First of all, we have the two fuel tanks. We have the left fuel tank, the right fuel tank. We have both fuel caps. That's basically like in your car. It's a cap that you can open, you put your hose inside, and you can fill up. Then the left one has a vent, as we can see right there. The vent is a pipe that connects the inside of the fuel tank with the outside in order to get rid of gases that can produce inside there, and they can be really harmful if they explode, right? Because as you know, liquid gasoline doesn't explode, but gaseous gasoline does. All right. Well, next we have the selector valve. We have it right there. Basically, this valve is gonna select if we burn fuel from both tanks at the same time, from the left tank only, or from the right tank only, right? So we have a position up there that is both. If we set that position, we're gonna be burning the same amount of fuel from left tank to right tank. If we set the left position, we're just gonna burn fuel from the left tank. If we set in the right position, we're just gonna burn fuel from the right tank. And if we set it here, as we can see, this is the same drawing, we set it to off, we can just cut the fuel for the rest of the system. If a malfunction happens or whatever, we have an emergency that requires it, we can just shut off the engine and cut all the fuel going inside, right? The next part is the fuel strainer. The fuel strainer is a part that is connected to the primer. It's basically a piece of equipment that is going to allow us to get some fuel inside of the primer and then squeeze it out and push it inside of the piston. Inside of the cylinder. All right. So that's what the primer is. As we can see it here. This is a primer. The primer is basically a syringe. It's basically a system that we can pull. When we pull, we get some fuel out of the system. We push in again, and that fuel goes directly into the inlet manifold. All right. When we have a cold engine, we need to start. The engine's not really gonna start smooth because it doesn't really have any fuel in the lines. It has a lot of air in the lines. So we just squeeze this fuel inside of the lines, inside of the carburetor, and we're gonna make this engine start way smoother. We use this in the first start of the day. The rest of them is not required because the fuel pipes are full of fuel, not air. All right. The last part we're going to be seeing now is the carburetor. Carburetor is basically a system that mixes water, it mixes air with fuel, right? We see that it's connected to the throttle and the mixture control knob. We will see in the engine section what these knobs or these control levers are. But I can anticipate that these two control the mixture of fuel and air and how much of this mixture is going to go to the engine, and all that happens in the carburetor. After the carburetor we have the engine. All right, so this is simple. It's simple. We have two fuel tanks, selector, a couple more systems, and we are at the engine. So it's a really simple system, right? So it features a simple system, a carburetor control, a selector valve, and a primer. That's the really big things you have to remember about the Cessna 172 November engine fuel system. This is the Cessna 172 Romeo. As you can see, the system seems a little bit more difficult to understand, but don't worry, we're just gonna break it down in pieces. The first part right here, we can see it highlighted in green. It's the tanks section, right? The first difference we can notice from this system to the other one, well, first, this is an injection system with gas as well. So there are going to be more electrical devices. It's going to be more complicated. There are going to be pumps that weren't there before. There are going to be gauges and instruments, transmitters that are not going to be there before. So that's all new, right? But the basic part of the system is pretty much the same. So we have these two tanks. We have the right tank, the left tank. That goes to the selector valve. The selector valve is a bit different. We have left, right, both. And to shut it off, instead of putting it in the off position, we have this fuel shut off button. We have to pull in order to cut all the fuel, okay? But the functioning is the same, okay? This is the same as before, right? We have the vent in the tank. We have a drain, right? We have 5 drains on each side. We will see in the procedure section how to really drain an aircraft to see that there's no water or any residue in the tanks that could affect the performance. These 2 tanks are going to transmit, right, with 2 transmitters, that fuel quantity to some kind of gauge here. Remember, if we have the Garmin 1000 fitted, these transmitters are going to transmit straight away to the Garmin, and we're going to get our indications in the Garmin 1000. After that, we have something that is new from this system, the fuel reservoir tank. All right, imagine you're doing maneuvers, steep turns, you're having some kind of turbulence, whatever. Your airplane is going to be shaking, right? So maybe this system, this valve, runs out of fuel for a second, and that can really damage the engine and damage the pumps. So we add this fuel reservoir tank here that is always going to be full in order to allow to always have filled up fuel in the system, even if you're turning, even if you're doing maneuvers with negative gears, for example, I don't know, even if you are shaking because of turbulence, you are always going to have fuel in the system. That's the warranty that this little piece of equipment is going to give you, right? After that, we have the auxiliary fuel pump. This is an electrical fuel pump we can use if we need it, right? Just to clarify here, the Cessna has the wings over the fuselage, over the engines. So in normal operation, we don't really need a pump, okay? The fuel just drops because of gravity. So this pump is only for special occasions like maneuvers. It's also used as a primer, by the way. There's a procedure we will be talking about later where you prime the engine, but we don't have a primer here. So we're just gonna use the auxiliary fuel pump as a primer, all right? But yeah, as I said, the normal operation is going to be off the most of the time. Then we have the fuel shut-off valve. This is this red button that I told you before. You pull it, and absolutely no gas is going inside of the engine, okay? That's a good thing about it. You don't have to turn the selector. You have to pull the fuel shut-off valve. After that, we have a couple more systems. We have another drain, okay? in case these two drains, we drained them and everything was clean, we still have one more. So in total, in this system, we have 11 drainage points, okay? We'll see it in the external inspection. So if some water, some dirt, something is inside of the system, we're gonna be able to drain it from here as well. After that, we have the engine-driven fuel pump. Okay, so this pump is driven by the engine all the time. The engine's moving, and it's pumping, is sucking all this fuel from the system inside of the engine, okay? Because it's an injection engine that needs a positive pressure, okay? We need a positive pressure, and that's why this engine-driven fuel pump is going to be working all the time at the same time the engine's working as well, all right? And it's going to pump this fuel inside of our engine. Then we have the fuel air control unit. This is kind of the carburetor to say somehow. We don't have a carburetor here, but this unit controls the ratio between fuel and air, and this is going to be connected to your mixture level in the cockpit. We will see this in the engine section. After that, it also goes to the fuel distribution valve, and from this valve, it distributes to the different cylinders, right? We have 4 cylinders, and the 4 cylinders are gonna get some fuel from this unit. And here's where the fuel flow indicator is gonna be connected, so we see exactly how much fuel our engine is actually burning. All right, so you might ask me, if this is the engine, what is this other line? Well, as you can see here, this is the fuel return line, right? The fuel return line is a line that makes the extra fuel that the injectors didn't use go back to the reservoir tank. So this is new in this system as well. Let's do a recap. In the other system, all the fuel that was going in was going to be burned, right? Because from the carburetor, all that fuel was going to be burned. We didn't need an additional line, we didn't need anything else. Here we have a constant pressure of fuel going inside the fuel distribution valve, all right? But that valve doesn't always need the same fuel flow. Therefore, the fuel that the engine doesn't need at that point is going to go back to the fuel reservoir tank to go back into the cycle again, right? So that way it's more efficient. It's way more efficient than the carburetor, all right? So it features an auxiliary fuel pump switch, and this is just to make the system work, of course. Features. As we said, we have an additional fuel pump for special occasions. We have this reservoir tank that is so useful. 2 uses of the reservoir tank. 1, it allows us to have fuel in our tanks and fuel in our systems continuously, and is a warranty of fuel flow in case you have maneuvers, negative G's, or turbulence, and it also allows for the fuel return line to be connected again to the system. Now, additional Garmin gauges. The big thing about this are the gauges, the fuel quantity and fuel flow indicators. If you have a Garmin, those connections are going to be fitted directly into your computer. And then the return line, as we said, there is a return line because the injection system is different from the carburetor engine. Now, this is the fuel system of the Cessna 172 SP. As we said, when we talk about the Cessna 172 SP, we're talking about a diesel engine, right? So we're talking about the diesel engine, a turbocharged diesel or kerosene engine. We are using Jet A or Jet 1, Jet Bravo, whatever, jet fuel, okay? So in the end, this is going to become more electrical devices because we need to control more gauges and we need to control more parameters, all right? So the system is going to be overall more complicated. All right, let's take a look at it. As you can see, this system is drawn the opposite as the other ones. The fuel tanks are in the lower part, the engine is in the higher part. Well, this is just because of the manufacture of the engine. It's a different manufacturer, so we get a different manual, but again, the fuel tanks are exactly the same. In each fuel tank, however, we have fuel tank temperature indication. I will go through this again in a minute. Fuel tank level indication and low fuel warning. So from the fuel tanks, these are the 3 informations we're going to be getting. So why temperature? Well, if you get the manual or you get any manual of a plane that burns jet fuel, the temperature of the engine, and not the engine, the temperature of the fuel always comes into play. When jet fuel cools down too much, it forms something called paraffin, okay, and it can block the fuel line. So it's really important to keep jet fuel in the correct temperatures. Each manufacturer, each builder is going to give you the guidelines. So if you have a diesel engine in your aircraft, I really suggest that you take a look at the limitations. Of course, we will go on the limitations in the section that's going after this one, in the section 6 of this course. But I encourage you to take the POH, take the manual, and really learn those temperatures, because if you get your fuel too cold or too hot, you're gonna run into trouble. Okay, so that's why we have a temperature indication, and that's why it's so important. After that, we have the fuel selector. In this case, the fuel selector is pretty similar to the Cessna 172 Romeo. In this case, it's pretty much the same. We have the fuel setup, we have the right, both, and left positions, and here is represented with logic hydraulic gates, but the system is pretty much the same, right? We have this selector. After this selector, we have again the reservoir tank. We have talked a lot about it in the Cessna 172 Romeo, and it does exactly the same thing, right? Then that's for the back part of it. The fuel is gonna go back into the tanks, right, in the return line. But there's a cooler. I already told you that fuel can get really cold, and now I'm telling you that there's a cooler. This doesn't really make sense, right? Well, don't worry, we'll talk about it in a second. Okay, after that we have another electrical pump. Yes, now we need this electrical pump because of the nature of the engines. These diesel engines need these pumps to operate, okay? We have an electrical pump that could be this the auxiliary fuel pump that we had before, but obviously the engine is going to feature another valve. There's the engine-driven pump, okay? So we have two pumps again. It's an injection engine. Well, it's not an injection, it's a diesel engine, but it's pretty similar to the injection principle. I hope my systems teacher doesn't hear me saying that. Anyway, we need these two pumps, right? After that, we have the shut-off valve. We already talked about it. The red button, do not touch. If you touch it, boom, the engine goes dead. After that, we have something called the fuel filter module. Everything together, no spaces, no time to talk. We have a fuel filter module. This filter is gonna tell, okay, is the fuel warm? Is the fuel cold? Do I have to warm it up? Do I have to cool it down? It's gonna mix this cold and hot fuel. It's gonna do a couple things, a couple logics. As you can see, we have multiple kinds of logic ways that connect the return line with the inlet line to make sure that the condition of this fuel is perfect for the engine. And that is that. And after that, we have the engine that is the consumer. The engine here is like in the injection engines. We're gonna be supplying a continuous flow of fuel to the engine, and the engine is gonna decide, well, now I want this quantity, now I want that quantity. The fuel that is going to not be used is gonna go back through the return line, right? We have the return line here, logic gate right here to see if we are mixing it or not. Then we have the fuel filter module, and after that we have the fuel cooler, okay? We don't want to put really hot fuel inside of the tanks. That wouldn't really be a good idea. And then we have a check valve, so nothing really goes back into this pot. So yeah, as you can see, pretty nice and easy, nothing too difficult, just a couple improvements, and yeah. I really encourage you guys to take a look at your POH and realize which system you're going to be flying, so you know more and you know how to operate it. Recap: these features the FADEC logic gates, the temperature control systems, and the temperature and pressure gauges. Okay, more gauges, we need more control, especially over the temperature. The FADEC is going to be controlling all these logic gates, all these temperatures. He's going to be the one in charge for throwing the nice and warm fuel inside of the engine, not the bad and cold fuel. So as a recap, we have the Cessna 172 November system that features a simple system with a carburetor control, a selector valve, that is this one that we have right here with 4 positions, and then we have a primer. Okay, remember this is the only system that features a primer because it's the only system that actually requires a manual primer, right? We have the Cessna 172 Romeo that features an additional fuel pump, reservoir tanks, really important as we said before, really nice improvement, additional Garmin gauges, we talked about them, and a return line. Remember why? Because the system doesn't use, the engine doesn't use all the fuel we throw at them, it only uses a part, so the part that is not burned, we are not gonna throw it away, we're just gonna put it back into the fuel reservoir tank. This is the Cessna 172 SP that, as we said before, it features FATEC logic gates or logic hydraulic gates that are going to make sure that the temperature control is good. We have this temperature control system and a lot of temperature and pressure gauges. Why? Because we as pilots and the FATEC are going to need this information to make sure that the engine operates correctly. So to sum up, we have seen the 3 different systems. The fuel system fits the needs of the engine. Therefore, 3 different engines, we're gonna need 3 different fuel systems, right? So as we can see in the basic system in the Cessna 172 November.